Now that we know about radians and we already knew about degrees, let's talk about how we would convert between radians and degrees. So here's what we know so far. We know that we can measure an angle in a circle using either degrees or radians. And we know that 360 degrees makes up a complete circle, which is equivalent to, in radians, 2 pi radians. If we reduce those and talk only about half of the circle, then 180 degrees represents the same space as pi radians. Setting up a proportion where we have in the numerator a partial number of degrees, which you'll see here in just a second, I'm going to write as an equation, or a formula. I'm going to let that be called theta. Theta is a partial number of degrees over 180 degrees. That's going to be equal to, in radians, I'm going to let it also be theta, but I'm going to have it be called theta sub r. So partial number of degrees over 180 degrees is equal to a partial number of radians over pi. That gives us a formula that we can use where theta over 180 degrees is equal to theta sub r over pi. Now, there's two variations of this proportion, and there are times when I like to use this variation more than I like to use this one. And I'll show you both here in just a second so you can decide. If I solve the first proportion for theta, and I could do that by multiplying each side by 180 degrees, then I can say that theta is equal to theta sub r times 180 degrees over pi. So what that does for me is if I'm given an angle measure in radians and I want to convert it to degrees, then I'm going to multiply it by 180 degrees over pi. Now, a variation of that would be if I'm given an angle in degrees and I want to convert it to radians. Well, let me go back over to the original proportion. Now I want to solve for theta sub r, so I'm going to multiply both sides by pi, and the pi's cancel out, and I'm left with theta sub r is equal to theta times pi over 180 degrees. So let's look at an example where in one of the examples we use the first proportion, and in the second example we use one of the variations. So part A, convert 126 degrees to radians. All right, so I'm going to use the first proportion, and I'm going to set up 126, which is my partial degree measure, over 180 degrees, and that's going to equal a partial radian measure, which I want to find, over pi. To solve this equation for theta sub r, I'm simply going to multiply each side by pi, and I'm going to reduce that fraction. So here's what I find out. I find out that theta sub r is equal to, now notice that the 126 degrees and the 180 degrees, the degree measures cancel out, which is good because radians are unitless. Their unit is a radian. And so we get that 126 degrees is equivalent to 126 pi over 180 radians. Now I can reduce that fraction. I think that 18 goes into each of the numerator and the denominator. And if I've done my math correctly, I should get 7 pi over 10. Now, what that says is that 126 degrees is equivalent to 7 pi over 10 radians. 7 pi over 10 radians is an exact angle measure for radians. I could put into my calculator 7 times pi, which would be, 7 times 3.14, so 21, 22-ish, and then divide by 10 to get around 2.2 something radians. But most of the time, we want to use the exact value of the radian measure. Okay, so 7 pi over 10 is that. Okay, let's do part B. Convert negative 3 pi over 4 radians to degrees. So I'm being given partial radians, and I want to convert those to degrees. So I'm going to use this second proportion, which is a variation of the first, that says that theta is equal to theta sub r, which has been given to me, so negative 3 pi over 4, and I'm going to multiply that by 180 degrees over pi. Now I like this because the pi's are going to cancel, and I'm going to be left with just an answer with the new unit of degrees. So this is going to be negative 3 times 180 degrees over 4. And I think if I do some reducing here, the 4 goes into itself once. And if I take 180 degrees and I divide it by 4, I get 45 degrees. And if I multiply, I get negative 135 degrees. So negative 3 pi over 4 is in the same location or measures the same angle as negative 135 degrees does. In addition to knowing the measurement in degrees of a circle, where a quarter of a revolution is 90 degrees, half of a revolution is 180 degrees, 3/4 of a revolution is 270 degrees, and a full rotation is 360 degrees, we can also identify some special angle measures within the quadrants. If I start with the first quadrant, half of 90 degrees is 45 degrees. So let's mark that on the circle. So half, if I go half of 90 degrees, that gives me 45 degrees. If I go 1/3 of 90 degrees, that gets me 30 degrees. And if I go 2/3 of 90 degrees, that gets me 60 degrees. So let's see if we agree with this. So starting on the positive x-axis and rotating counterclockwise, I first approach 30 degrees, which is our first special angle. And then if I go halfway, I get to 45 degrees. And if I go 2/3 of the way, I get to 60 degrees. And if I go all the way, that whole quadrant, I get to 90 degrees. Now, I bet that you could do that for the rest of the quadrants using that same idea. For example, between 90 degrees and 180 degrees, what is half of that? Well, if half of 0 to 90 was 45 degrees, if I simply add another 45 degrees to 90 degrees, I get 135 degrees. I'm going to leave the rest of this to you to practice, and we'll go ahead and fill in this circle with the degree measures. And I think that it feels, hopefully, a little bit intuitive. Now, the second piece of this are radian measures. And radian measures, we've just learned how to convert from degrees to radians, but we haven't done that on a full circle. So let's talk about what we know so far. What we know so far is that, let's see here, 0 degrees would be the same as 0 radians, and 180 degrees would be pi radians. And if I go all the way around the circle, that's going to take me to 2 pi radians. So how do I figure out the rest of these? Well, some of these are intuitive, but if they're not intuitive, then you can use the formulas from the previous slide. But let's go with our intuition first. Between 0 and 180 degrees, half of that is 90 degrees. So using that same idea, what's half of pi? 1/2 of pi is pi over 2. All right, so 90 degrees can also be called pi over 2. So if you think about this, from 0 radians up to the end of the first quadrant is 1 pi over 2, and then going through the second quadrant is 2 pi over 2, then 270 degrees would represent 3 pi over 2. And going all the way to 2 pi, I guess we could call that 4 pi over 2. But notice that 4 pi over 2 does reduce to 2 pi. Now the reason I'm talking about this is because using that idea of fractions is going to really help you fill in the rest of these values. Let's take a look at 45 degrees. 45 degrees in radians would be half of pi over 2. Well, 1/2 of pi over 2 is pi over 4. All right, so 45 degrees is pi over 4. And let's see, 30 degrees, that was 1/3 of 90 degrees. We're going to say 1/3 of pi over 2. And I didn't explain it on the last one, but whenever you use the word of, that typically means multiplication in math. So I'm just multiplying straight across to get pi over 6 for 30 degrees. And then for 60 degrees, that's going to represent 2/3 of pi over 2, or 2/3 times pi over 2, which is 2 pi over 6, which reduces to pi over 3. Okay, so let's think about this for a second. And I'm going to try not to be too messy here, but I think it'll help if I do some drawing on here. So from 0 radians to pi over 6 is 30 degrees. And then if I go another 30 degrees, that took me to 2 pi over 6, which reduced to pi over 3. If I go another 30 degrees, that should be, let's see, we said 1 pi over 6, we said 2 pi over 6, this is going to be 3 pi over 6, and 3 pi over 6 reduces to pi over 2. Now, why am I telling you that? Because if we keep going using that same idea, so another 30 degrees, another 30 degrees, another 30 degrees, I can just keep counting in pi over 6s. So 120 degrees would be 4 pi over 6, which reduces to 2 pi over 3. 150 degrees would be 5 pi over 6, that does not reduce. 180 degrees would be 6 pi over 6, which is pi. Good, that checks. Let's keep going. If I keep going 30 degrees, 30 degrees, 30 degrees, I should get 7 pi over 6, 8 pi over 6, or 4 pi over 3 for 240 degrees, 9 pi over 6, which reduces to 3 pi over 2, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, which doesn't reduce, and all the way back to 12 pi over 6, which reduces to 2 pi. All right, let's use that same idea for the 45 degree angles. We said that 45 degrees is pi over 4. If I go another 45 degrees, that takes me to 90 degrees, or pi over 2. So we have, let's see here, 1 pi over 4, 2 pi over 4, looks like 3 pi over 4, 4 pi over 4, which reduces to pi, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So this is a little bit messy. On the next screen, I'll give you a complete circle. If you want more information helping you convert radians to degrees or identifying radians on a circle, I have a YouTube video that you should take a look at. This feels like a lot, but it's not really. It's a matter of memorizing the first quadrant. And if you can memorize the first quadrant, then you can easily come up with all of the special angles on this complete circle. And that's what you should be working for. Within the first couple of weeks of trigonometry, you should make it a goal to have this circle memorized. It'll make your life so much easier. And as promised, here is that complete circle with all of the special angles identified, measured in both degrees and radians. Make sure that you've got this written down correctly so that you memorize the correct thing, but also pay more attention to not just memorizing it, but going through that process of developing these angles so that really all you have to memorize is the first quadrant. Hope that this helps.